A program is a set of instructions. If you remember our cooking analogy, a program is like the recipe that is followed to get from the input to the output. A program will create variables and assign values to them. Variables are like containers in which you can keep values. A function is like a transformation. It takes these variables and does something with them. A function is like a food processor. This is something we have already talked about. You can take a variable, pass it into a function, and get an output from that function. The program will call a function, pass in a variable to it as an input, and get output back. Now, the part of a program that calls a function and passes it some input and waits for the output from that function is called the calling code. The calling code is the part of the program that calls a function and passes it some input. Now, the calling code usually passes in inputs to the function in the form of variables, and these variables are called arguments for that function. So the inputs to a function are called arguments. So function will give an output to the calling code. It will give back information to the calling code in the form of a variable which is known as the return value. So the function takes in inputs which are arguments, processes them, and returns a value to the calling code. Now the calling code could actually be inside the function itself. The calling code itself could be something which is inside the function. A function could call itself. The technical term for a function calling itself is called recursion. Let's understand this in a little more detail. You have some calling code and you have a function. The calling code will be a set of instructions. So it will have different instructions like creating a variable. Another instruction could be to assign a value to some variable, and at some point in the calling code you would call a function. At that point the function takes in an argument which the calling code passes it and does some stuff to it, does some stuff with it, and sends a return value back to the calling code. So the calling code passes in an argument to the function and the function returns a value to the calling code. Once again, arguments are inputs that are passed to a function and the return value is the output which comes out after a function does stuff with the arguments. Then the calling code continues on and it will do some stuff with the return value from the function. Variables which are created in the calling code and then passed in as arguments to the function behave in a certain way. This is a little bit tricky, so let's go into it in a little detail. Let's take this example. What will this code print? You have a variable a that is created in the calling code and the value 5 is assigned to it. Then we've defined a function. Do some tiddly stuff. It takes in an argument b and then it changes b to b plus 5. Now if you print the value of a before this function is called and after this function is called, what will this code print? Will the change made to the variable inside the function reflect once the function returns? you have a variable initialized with some value here, and then you call a function, pass in that same variable, the function does something to that variable. So in the calling code, do some tiddly stuff of A, basically passes A, the variable, as an argument to the function, do some tiddly stuff. At this point, the code in the body of the function do some tiddly stuff will be called. B equals B plus 5 is the code in the body of the function. This basically takes in any argument that is passed into the function and does something with the value of the input that is passed into the function. It increases that value by 5. So to understand whether this code is going to print 5 or 10 is the big question. And to answer this question, we have to answer the meaning of existence, or at least the meaning of existence of variables. To understand that, let's understand how data exists in Python. All data in Python is in the form of objects. Now, when we assign a variable a value like a equals 1, a is the variable and 1 is an object. Numbers, strings, lists, and dictionaries are the different types of variables, and they are also the different types of objects. Now these types are like species. Say for example, different breeds of dogs, or trees are a species. Each type is like a species, and a specific animal or tree or organism is like an object. So an object is like a puppy, and a variable is the name you give the puppy. Now functions usually do two things with a variable. One of them is called reassignment. What happens when you reassign a variable? You basically reassign it to a new object. That is a new puppy. You just take the name tag of the old puppy and give it to the new puppy. The old puppy is still there, it still exists, and nothing has changed. But the name tag A has now been assigned to the new puppy. So let's look at reassignment inside a function. So here is some code. The calling code starts with assigning the value 2 to the variable A. So basically it takes a name tag A and puts it on the object 2. Next, the calling code calls the function f and passes it the argument A. This basically creates a duplicate name tag A on the object 2. Now inside the function, this name tag A is assigned to a new object 3. So this duplicate name tag, the green color A tag, is what gets assigned to a new object 3. The original name tag is still on the object 2. Now in the calling code, the blue name tag A is what exists. So when you try to print A, the code will actually print 2. Reassignments in a function therefore never reflect in the calling code, because the reassignment only exists inside the function. The duplicate tag that is created for that function is the one that gets reassigned. The original variable or name tag doesn't change. This is true regardless of whether the variable or object is a number, string, list, or dictionary, any type of variable. Now, as we said, functions do things with and to the arguments that are passed into them. One of the things that they do is reassignment, and the other is modification. Some objects, however, can be modified and some cannot. The objects which cannot be modified are numbers and strings. These are called immutable objects, and objects which can be modified such as lists or dictionaries, are called mutable objects. Mutable objects are like puppies. They can be modified. For example, you can clip their claws. They have parts which you can add or remove. Immutable objects are usually very simple objects. Like for example, some species like amoeba are very simple. Once born, they don't change. When you try to mutate them, basically you get 2 completely new amoeba. You only get 2 new amoeba which are reproduced from the old amoeba. Let's look at modification inside a function, specifically to immutable objects. So for example, we have a equals 2 and we tried to modify it to a equals a plus 5. So first the calling code assigns the value 2 to the variable a. So it takes this name tag a and puts it on this object 2. Then it calls the function f and passes it the argument a. This creates a duplicate tag on the object 2. Now inside the function, when it tries to modify this value a, it actually cannot do it because numbers are immutable. Since they can't be modified, when you try to change them, you just get a new object. So in effect, the name tag a inside the function just gets reassigned to the object 7. The original variable a, the blue name tag, is still on the object 2. So when you try to print it, you will get 2. Therefore, when you try to modify immutable objects such as numbers and strings inside a function, it will never reflect in the calling code because it is basically just like a reassignment to a new object. Now let's see what happens when we try to modify objects like lists or dictionaries. These are mutable objects which can be modified. So let's say we assign the name tag a to the list with only one element 1. We next call the function f of a and pass it this variable a. It creates a new name tag on that same object. Now inside the function, we are modifying the list. A list can be modified in place. So this will just append 2 to the same object, which has the effect of modifying the list which is assigned to the variable a in the calling code as well. So when you try to print it, you will get a modified list. Therefore, modifications to lists or dictionaries and such mutable objects do reflect in the calling code. Now all of that was a little bit mind-bending, so let's recap once again what we learned. Reassignments in functions never reflect in the calling code. So let's take an example where we try to reassign different types of objects. Some num, some string, some list, some dictionary. We have a number, a string, a list and a dictionary, and each of these is reassigned in the function that reassigns. But none of it reflects when you print them in the calling code. The values of all the variables before the function is called and after the function is called remains the same. This is because when you tried to reassign it, you basically took the duplicate tag that was created by the function and put it on a new object. The original name tag or the original variable is still assigned to the same value. Numbers and strings, which are immutable objects, cannot be modified, but lists and dictionaries can. So lists and dictionaries can be modified inside a function, and here is an example to show you this. Once again, we have a number, a string, a list and a dictionary, and we have a function that modifies. Now the function tries to modify a number by adding a number to it, a string by adding a string to it, a list by appending something to it, and a dictionary by changing the value of a given key. Before the function and after the function, the number and string still remain the same, but the list and dictionary have been modified. Numbers and strings cannot be changed. If you try to modify them, the effect is the same as trying to reassign them to a new object, which, as you know, cannot happen. Lists and dictionaries, however, can be changed in place, so their contents can be changed when you pass them to a function. You cannot take a list and dictionary and assign it to a new list or dictionary, but you can modify the contents in place. Therefore, modifications to lists and dictionaries do reflect in the calling code. Here are two simple rules to help you remember what you just learned. You are what you are. Nothing you go through can change that. Basically, when you translate this to Python, it means that nothing can be reassigned. Nothing can be changed to a completely different object. The other rule is that anything you go through can change you a little bit. Unless you are really simple, then you can't be changed at all. Translated, this means that lists and dictionaries can be modified inside a function in Python, but very simple objects like numbers and strings cannot. Pass by object reference is what we actually learned. This is how arguments are passed to functions in Python as well as in Java. Pass by value and pass by reference are the other paradigms by which you can do argument passing to functions. Pass by object reference means that some changes are permanent but not all. In pass by value, you are passing in the value inside the variable to the function. So nothing that is done to that value is actually reflecting in the calling code. So nothing is permanent. In pass by reference, everything is permanent because you are passing in the location in memory for that particular variable to the function. So anything that resides in that location in memory gets changed. This is used in C++ in some situations. Pass by value is used in C, and pass by object